So, good evening, ladies and gentlemen. Today I will be doing a YouTube video rather than an Adobe Connect. I'm finding that Adobe Connect is not working for me tonight. So, today's topic is B3 percentiles, and we're going to take a look at what you can do with percentiles. So in this case, I'm going to start off by showing you something that I think is fairly intuitive. So if you take a look at this nice chart, you can be overwhelmed at first by the total number of different pieces of information that are on here. But once you take a look at what the things are, it becomes quite manageable and quite intuitive. So on the x-axis, you have the age of a boy in years. On the y-axis to the left, you've got the boy's weight, either in kilograms or in pounds. So if you haven't figured out yet, this is a weight for age chart showing the percentiles, so the relationship between the age of a boy and his weight. So if you look at the colors on the right hand side, you'll notice that there's a legend, and the legend corresponds to regions on the graph. Now, you'll notice at the top there's the 95th percentile, 90th, 75th, 50th, 25th, 10th, and 5th. So each of those lines represents a lower limit and an upper limit. So if you're looking at the very bottom gray section, you'll notice that there's a 5th percentile, it's written 5th, and it corresponds approximately with a weight of 55 kilograms. So when you look at this, you can see that a 20-year-old male who weighs less than 55 kilos or less than 120 pounds is in the bottom 5th percentile, bottom 5th percentile. 5th percentile? Yeah, 5th percentile. And then on the flip side is, if you've got a male who at age 20 weighs more than 95 kilo, they also happen to be at the 95th percentile. 95 kilos in pounds is 210 pounds. And then you've got a whole range of weights in between. So when you look at this, it's fairly intuitive. You can see that on the far left, at age 2, the range of weights that you would expect for a boy ranges between 20 and 34 pounds, so that's about 9 to 15 kilo. So if there's not a huge amount of variation. But then once you get to the 20-year-old adult, you'll notice that the variation has grown considerably. Well, at least in absolute terms. Relative terms, perhaps not. So, you've heard the word percentile many times. You've heard me use it a few times. So, a percentile tells you the relative position of an individual in a group, or an object in an array. So in this case, we have a young boy, and his relative position compared to his father is that he is shorter. Now, the thing that you do need to remember always is that the percentile and the percent do not mean the same thing. So percentile and percent, they are not the same. So let's take a look at a term, and we'll use the term 55%. So imagine the scenario where you get a 55% on a test. I hope nobody gets a 55% on my tests, but if you do, well, you'll be able to figure out your percentile. So if you got a 55%, typically it means that 55% of your answers are correct. So that means nearly half of your answers would be wrong. Now, let's also assume that you're in a class of 20 and that 20 people wrote that test. Only 3 people in your class got a higher mark than you. So that means that it was a really tough test, or as a class you did not study very well. So, sad face. Now, consider the percentile portion of this. So that 55% means that you are at the 80th percentile. 3 of your classmates got a higher mark than you. 16 got a mark lower than you. So now if you look at a ranking in your class, you can see that you happen to be the light blue person. So you'll notice that 3 people above you, the black, the light orange, and the dark orange, they got a higher mark than you. The rest of the class got a lower mark than you. That places you at the 80th percentile. So now let's take a look at the way that you write it. So percentiles, or P sub x. When you're talking percentiles, it means that it divides a data set into 100 equal parts. So 1% all the way up to 99%. Now we can even talk decimals, just to add a little bit of confusion. So what does the percentile tell you? So it tells us what percent of observations have a value less than the value we're talking about. So the key term here is less than. You're always remembering when you're talking percentile that you're talking the group that has got a value less than the value you're talking about. So let's recall our example. We've said that you're at the 80th percentile. That means 80% of the entire group has a mark that's lower than yours. So if you're talking a group of 5, that means you could reasonably expect that 4 out of the 5 have a lower mark than you. So in this case, if there's a group of 5, you would have the highest mark. So let's take a look at an example. P65. So we got 2 cute little cartoons there. You can pause and look at them if you wish. P65 is not a weapon, it's not a disease, and it's not 65%. So what is it? It's actually the value of the 65th percentile. So that means that 65% of the data set is less than that value, and we can stick an actual numerical value on it. So I'm going to use my sons as an example. We can talk about children that are 2 to 20 years old, and on your website you've gotten an example of a growth chart for boys between ages of 2 to 20 and also girls ages 2 to 20. I'm using the boys chart because, well, I have 2 young boys that I can use as examples. So they're calling this stature for age and weight for age percentiles. Stature is a fancy way of saying height. So we've got Marcus. He's my youngest. You can see him here devouring a pancake and an egg a few nights ago. So his vital statistics are, he's 2 years old. Well, he's actually a week less than 2 years old. His height is 91 centimeters. His weight is 13.5 kilograms. So now we throw up this little segment of the growth chart. Without any context, it probably is quite meaningless. I've spent the last 3 years looking at growth charts. That's what you do when you've got young kids. So I know what all of this means, but let's break it down. So first of all, you see where the red line appeared. And if you go to the very bottom, you'll notice there is 2. That 2 means 2 years old. 3 years old, 4 years old, you get the picture. That's the x-axis. So then I'm going to draw a second red line, and that's at the 90 point. Oops, I guess it should have been 1 higher. Anyway, you'll notice that this horizontal red line joins up with the 90 point. It should actually be 91. So, nice big red arrow. 90 represents height in centimeters. And then to the left of it, you've got height in inches. 30, 32, 34, 36. So 36 inches corresponds roughly with 91 centimeters. So I guess my son is 36 inches. And then if you go to the bottom, you'll notice a second red line appear. And that is at the 13.5 kilogram mark. Yes, that is 13.5 kilograms. So let's take a look at what that means in terms of the percentiles. So let me go back to the previous slide, and you'll notice here on the right hand side we've got the percentiles listed. So the bottom solid line is a 5 percentile. The middle solid line is the 50th percentile. That's the median, halfway point. And then you've got the 95th percentile at the top, the last dark line. And then in between that you've got 75 and 90. So you got 5, 10, 25, 50, 75, 90, 95. Now let's take a look at Marcus's vital statistics. So for height, you remember he is 91? So 91 at 2 years old happens to line up with the second last line. So the middle line is 50, the middle solid line is 50, and the second one is 75, the third one is 90. So in this case, he would be at the 90th percentile. Now I can tell you, he is not quite that tall. He is certainly not 90th percentile tall, but he is tall. And then for weight, again, you take a look at the line. The middle line is the 50th percentile. The next one is 75th percentile. So according to this, he's slightly less than the 75th percentile. Now, it does kind of make sense. He is quite a lean child. He's sturdy, but he's lean. And he is considerably taller than his peers. But he's not... Well, actually, no. I was going to give you an explanation about why the 95th percentile, or the 90th percentile doesn't quite work, but it doesn't work. I'm going to have to double check his height and see if he is not exceptionally tall. Anyway, continuing on. We've got Anton. He's my firstborn, my oldest. He's 3.5. He's 103 centimeters. His weight is 17 kilos. Now, if we look at the same chart, we've got 3.5 years, the vertical red line. We have at the top his height, 103 centimeters, and at the bottom we have his weight, which is 17 kilograms. Now, his height falls between the 75th and the 90th percentile, so he is still quite a bit taller than the average. Not quite as exceptionally tall as his little brother, but probably within margin of error. And the same with his weight. He is more than 75, lower than 90%, which does make sense. He is a little more solid than his brother. He always has been. He came out at 9.13. His little brother came out at 9.3. That's 9 pounds 13 ounces and 9 pounds 3 ounces. Neither of them were small babies. And by the way, just for the record, I'm 5'9", which places me at like the 45th or the 50th percentile. So at this rate, my sons will be looking down at me. And oh yeah, my wife is 5'9", which places her well above the 50th percentile. So percentile graphs, what can you use? You can use them to predict future height. And one of the challenges I'm going to suggest is to try to use the CDC chart that you've got and predict how tall Marcus and Anton will be when they're 16. And if you want to, you could post the results in the class lounge, and we'll see what people think their heights will be. Okay, so one of the things that you should be aware of when we talk about percentile graphs, and especially in this case when we're talking about height and weight, you also have to think about a person's genetic ancestry. Now, the graphs that you've seen there from the CDC, that's the Center for Disease Control, it's an American organization. It's an aggregate of many different people with many different backgrounds. Canada has a somewhat similar genetic profile. So it means that you've got people from very different genetic ancestries. Some people have very slow growths early in life. Other people become quite tall. So anyway, it's an average. That means that if you're wanting to do things accurately, you need to create customized charts that take into account a person's genetic ancestry. So one of the things that is quite obvious is the birth weight of babies. Certain groups have babies that are quite heavy, other groups have babies that are quite light, and one of the problems with that is that when nurses and doctors look at the birth weight charts, you have babies that end up being declared underweight, severely underweight, or severely overweight, which places them at higher risks of certain ailments. But the reality is that these kids can sometimes be they're lighter, but they're not so light that they're in danger territory when you look at the genetic background. So, for example, I have a colleague who had a baby, I believe the baby was 5 pounds, 5 ounces. My apologies for using imperial on these measures. It seems to be the only place in Canadian society that people still do that. Anyway, if you looked at the average birth weight chart, their baby was severely underweight in like the bottom 5%, which puts them at quite a disadvantage, and it means that you have to really pay attention medically. But when you look at the birth weight for his background, it's expected, and the baby was considered quite normal. And one of the things that's happened in the last few years is that customized charts have been made. Here in Toronto, we've got St. Michael's Hospital, and they were the pioneers in this. They created customized charts, which are much more reliable, much more useful for doctors to use. So there you go, turning data management into something that helps improve medical outcomes. Okay, so now for some stats vocabulary. So there are special cases when you're talking about percentiles. So I want you to recall one thing. Percentile means that a certain percentage of the data points, they end up being lower than the current value. So remember that thing, less than or lower than the current value. So we've got the most common special case. We call it the median, P50. So that's the percentage of data points that are lower than the current value. So that's half of the data set. And then we've got another set of special cases. We call them quartiles. You can go up by 25%. So we got the first quartile, P25, we got the third quartile, P75, and you can also surmise that we've got the second quartile, which is P50, happens to be the median as well, and then of course the fourth quartile, P100, which means every single data point in the entire data set. I'm not going to get into P100 because that requires, well, that gets more into the theoretical realm. We also have a special case called the decile. So quartile, quarters. Deciles, that's where you're talking about tens. So break up 100% into tens and you get 10% segments. You got decile 1, D1. D1 is P10. D2 is P20. And you can imagine all the way up to D10 is P100. Now, when you're talking percentiles, what is it you want to know? Two things. First, you want to know the position of the percentile in the array of numbers. Second, you want to know the value of the number that is that percentile. So I've color-coded. The position is orange, the value of that position is blue. So if we're saying P50 is 139, then we would say that the 50th percentile has a value of 139. So once again, the 50th percentile, so the median, has a value of 139. That means that half of the data points have values less than 139. Okay? So those are the two things that we care about when it comes to percentiles. The position, which is P50, and the value, which in this case happens to be 139. Could just as easily have been P41, and your value could have been 10,266,023. So, of course, this is math. There is a formula. Now what you need to do is you need to arrange your data from least to greatest. And then you've got a formula which allows you to figure out the position of any data point, provided you know how many objects are in your data set, and provided you know what percentile you're interested in. Okay, so you've got the position of your percentile within the array, and that's going to be the total number of objects plus 1, all over 100, multiplied by the exact percentile you're interested in. So let's take an example. Now in this case, we've got the position number within an array. N is the total number of objects, X is the percentile you're interested in. So If the total number of objects is 72, and you want to know the 25th percentile, then you've got to figure out which data point represents that 25th percentile. So you're going to plug in your formula. 72 plus 1 divided by 100 times 25. You're going to expand and simplify. So equals 0.73 times 25, and in the end you end up with 18.25. That means that the 18th data point and a quarter is going to be your 25th percentile. So you remember, you got 72 pieces of information in there. Your 18th, and then a little bit more, is the 25th percentile. So everything below that is less than the 25th percentile. Now you're going to do a little bit of interpolation to find the exact number that corresponds to the 25th percentile. So 18.25 suggests that you are 1/4 of the way between the 18th and the 19th object. And that means you got to do some very simple math, an addition and a division. So let's take a look at the example. We've got up here a bunch of data points. We got 22 of them in total, and you'll notice very tasty ice cream bar. I can't have ice cream bar unless I've got lactate, but hopefully none of you suffer that affliction yet. So we've got 22 data points. N equals 22. Now we're asked to determine 4 things for this data set. We're asked to determine the median, the first quartile, the third quartile, and the 4th decile. So what I like to do is I'd like to turn them into P's. P50, P25, 75, and P40. Okay, so now, first thing you do, you order everything in your data set from smallest to largest. So let's take a look at how that's done. It's done for us in this case. 111 all the way up to 190. And then just for the sake of space, we've got 3 rows, 190, 197, and then all the way across to 310, and 319 across to 439. So ordered smallest to largest. So you have to sort your data set to do percentiles. If you're using Microsoft Excel or a stats program, SPSS, SAS, what have you, it'll do it automatically for you. If you're doing it by hand, you are going to have to make sure that things are sorted. Now, recall that the formula for the position is what's shown below. So that's the total number of data points plus 1 divided by 100 times the percentile you're interested in. So, now let's take a look at how we get the median, P50. So, we know that there are 22 data points. So we're going to do 22 plus 1 divided by 100 times 50, because we wanted the 50th percentile, which corresponds to the median. And when we do the math, we end up with 11.5. That means the median lies between the 11th and the 12th positions. And with the 0.5, it tells us it lies exactly halfway. So we do the math again. So we're going to take the value of the 11th position. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 happens to be 209. So the 11th position is 209. And then we're going to add the 0.5. So we're going to have to add the 0.5, which is half of the difference between the 11th and the 12th position. And you've got to make sure that you get your signs right on this, because otherwise you get an incorrect P50. So in this case, we've got the 12th value is 234. We subtract 209. We end up with the difference of 25. And then we've got to go halfway point, which is 12.5. So 209 plus 12.5 is 221.5. That means our median is at 221.5 calories. Half of the ice cream bars have a caloric content that is less than 221.5 calories. It could be some of them are smaller. It could be some of them have less sugar added. Those are the 2 primary reasons. So, in the end, that is our median. And if you were to look at it, you notice that 11 of the data points would be less than the x, and 11 of the data points would be greater than the x. Now let's take a look at the first quartile. The same thing. We got 22 data points. We want to find the 25th percentile. We punch in the numbers. We end up with 5.75, 3/4 of the way between the 5th and the 6th position. So once again, we take the 5th value, which is 151. So 1, 2, 3, 4, 5 happens to be 151. The 6th position is 179. So we take 179, subtract 151, 28 times 0.75, and in the end that is 21. So 151 plus 21, 172. We got 172 calories for the 25th percentile. A quarter of the ice cream bars have less than 172 calories. Remember, you can pause this video and rewind anytime. If I'm talking too quickly, you'll be able to. I'm not sure if it'll be able to give me subtitles. It depends on a few things in their algorithm. So there is the 25th percentile. 75th percentile, third quartile, exact same process. In this case, we got 17 1/4. So we're going to do a quarter of the difference between the 18th and the 19th, sorry, the 17th and the 18th position. And in the end, that gives us 323.5 calories and an X that pops up right there. So that's 3/4 of the data set below the X. And the 40th decile, same thing. We've got 9.2, so we're going to have to do 0.2 times the difference of the 9th and 10th positions.